at the cathode now. What happened at the cathode? So at the cathode, we need to visit our electrochemical series. So we need to visit our electrochemical series before we can talk about what happens at the cathode. And it is also very easy. Electrochemical series is the arrangement of metal cations in their, according to their what? To their reduction power, or according to their reducing power, or according to their reactivity. That's why we call it reactivity. We call it either reactivity series or we call it electrochemical series. So now I think there was an acronym, if I can remember. It is COLA. Is it, what do I call it? I think it's, yeah, this is COLA, Yoruba language. COLA never, what is for sodium. COL, Mr. Magnesium, aluminium, zinc, lead. Sorry, iron, Fe. Acid will be lead. And I think hydrogen, copper, and I think the next is silver. So I think, yeah, silver, I think gold, Hg. Yeah, so anything after silver, you don't need to bother ourselves too much. So potassium. So if I need to draw, let me make this one smaller so we can see it. Yeah, let's make it, reduce the size, and then we place it here. Yeah, don't mind that this bends. So this is the reactivity series, from the least reactive to the most reactive. So potassium is the most reactive of all of them, and then sodium, what do you call this one? Gold is the least reactive. So this is most reactive, and this is the least reactive. Now, so how does this one play out at the cathode? Remember, at the cathode, we have competition between, in this case, competition between a metal cation and a hydrogen ion. Always a metal cation and hydrogen ion. Hydrogen ion from water. This one is from the salts. Now, competition between both of them. You can see, and then we have hydrogen here. You can see our hydrogen here. Yeah. So all this metal up from potassium to lead, they are more reactive than hydrogen. But hydrogen is more reactive than copper, silver, what is this one? Gold, and others down, heavy metals down. Now, so competition between sodium ion and hydrogen ion. Who is going to get discharged? So the rule is that let me write it if you want, or I will state it first. The rule is that the ions of metals that are more reactive than hydrogen prefers to stay in the solution and allow hydrogen to go and get discharged. Again, ions of metals that are more reactive than hydrogen prefers to stay in the solution, and then they allow hydrogen to go and get discharged at the cathode. And the opposite is the case for the ions of metals below hydrogen, that is, that are less reactive than hydrogen. Ions of metals that are less reactive than hydrogen will go and get discharged. Hydrogen is their boss now. Hydrogen will stay in the solution and push them to go and get discharged. So this, from potassium to lead, they are boss to hydrogen. They stay in the solution, and then they push hydrogen to go and get discharged. Whereas copper down to gold, they are what? They are like servants to hydrogen. So hydrogen will push them to go and get discharged to stay in the solution. Again, ions of metals that are more reactive than hydrogen prefers to stay in the solution, and then rather they allow hydrogen to go and get discharged at the cathode. So if you get that rule, that's all. Life is easy. You will get you've gotten electrolysis of what? Of aqueous solution. So let us now face this electrolysis of sodium chloride solution. So let's assume that it is electrolysis. I will do for dilute and I will do for concentrated. So electrolysis of concentrated sodium chloride solution. So the ions in the electrolyte are Na plus, Cl minus, H plus, and OH minus. These are the 4 ions in the electrolyte. And remember, at the anode, the ions present at the anode are, because anode is our positive electrode, so it's going to be Cl minus and OH minus. And the nature of the electrolyte, so electrolyte, our electrolyte is concentrated, it's Kong halide. Kong what? Is concentrated, I would say that is concentrated, and halide is present. So in that case, halide will be discharged. So I'll write it, I'll say halide. What is the halide? Cl minus will be discharged. That is, it will remove its charge. So if halide gets discharged, let's write the equation for that. Our chloride ion gets discharged, remove the charge, it becomes what? Chlorine atom. So we can call it a chlorine molecule, and then we'll put 2 here. To balance the equation, we'll put 2 here. So this is our product. If they ask you, what is the product at the anode? This is the product at the anode. Our product anode is what? Is chlorine gas. So this is product at the anode. Now, we are done with what happens at the anode. So at the cathode, what happens? Now, remember, the ions in the electrolytes, let's write that. That is, the ions that will migrate to the anode, to the cathode. So the ions that will migrate to the anode, to the cathode rather, with its negative electrode, are H plus and Na plus, sodium ion and hydrogen ion. So remember that sodium ion is an ion, is the ion of a metal. Let me write it that way. Is the ion of a metal that is more reactive than hydrogen. Remember, when you have the ions of a metal that is more reactive than hydrogen competing with hydrogen, that ion will prefer to stay in the electrolyte. It will be the boss and stay in the electrolyte. Send hydrogen out to go and get electron at the cathode. So, because of that, I will say hydrogen ion will be discharged. So, the equation of the reaction is going to be hydrogen ion that needs electron will get 1 electron and become hydrogen atom. So remember, it has to be hydrogen molecule. So this one become H2, it's become 2 hydrogen ion, and then 2 electrons are collected. So the product at the cathode is hydrogen gas. So let's summarize the electrolysis of constant. Oh, before that, but let's summarize it quickly first. The products, I'll just say the products of NaCl aqueous concentrated at the anode, which is our positive electrode. The product is what? Can you remember? Chlorine gas. In the cathode, what is the negative electrode? The product is hydrogen gas. We need to mention something before we go. They may ask you, what is the nature of the electrolyte after the electrolysis? That is, when hydrogen ions and chloride ions have left the electrolyte, what is the nature of that electrolyte? Remember what you're going to do in this case is just draw a box. You have Na plus, we have Cl minus, we have OH minus, and H plus, and delete this ion. This one has been discharged to become hydrogen gas. Delete Cl minus. Cl minus has been discharged to become what? Chlorine gas. What do we have left? Na plus and OH minus. What is that? Sodium hydroxide. So you have another product. So your two products. You started with concentrated sodium chloride and you ended up with chlorine gas when you are going home, hydrogen gas when you are going home, and sodium hydroxide when you are going home. So you have two products at the electrodes and one product at the electrolyte when you electrolyze concentrated sodium chloride solution. Let's look at dilute sodium chloride solution before we go.